In the last session, we have calculated the SSIM score as 31%, which is a pretty low value. And in this session, we'll continue with the calculation of threshold and contours of the images. In CV2, all these functions are predefined, so no need to worry about them. So we'll start with CV2.threshold and find out the threshold of the images. Similarly, we will find out the contours using the find contours function. And these contours are then grabbed by IMUtils function as IMUtils grab contours. Here you can see that CV2.threshold, here we pass the difference between the difference that we have calculated about 0 to 255, and we convert this into threshold binary and similarly threshold OTSU. We will save this value into thresh variable and the contours into the control variables. Now let's run the cell and save these values. So the threshold function, it applies the adaptive threshold to the image which is stored in the form of array. This function transforms the grayscale image into a binary image using a mathematical function in the backend. Similarly, for finding the contours, we need to use the functions find contours, and it works on the binary image to retrieve the contours of the images. These contours are really useful tools for shape analysis and recognition. So we will use IMUtils to grab these contours and apply them later on. So the next step is to create a bounding rectangle of the image. So creating a bounding rectangle, we need to use the contours. So we are looping over the contours we have stored in CNTS. And we are creating a CV2.rectangle over the image using this function. So in this loop, as you can see, we are trying to save the CNTs in C, and we are using X and Y as width and height respectively. That is CV2.bounding rectangle. A rectangle has X width and Y as height. And for this, we are using CV2.rectangle function passing the original image. This will create the bounding rectangle for the original image, while the next one will create the bounding rectangle for the tampering image. So the bounding rectangle, it helps us in finding out the ratio of width to height of the bounding rectangle of the object. We compute the bounding box of the contour and then draw the bounding box on both the input images to represent whether these two images are different or same. Now let's run this cell and create our bounding boxes. As you can see, the code has run, so we have created a bounding rectangle. Now we just need to visualize the image using different functions. So first we will display the original image with the control that we have created. So this is our original image with rectangle boundaries. So you can see here, this is the original image with the contours on it. For income tax, we are having a contour for this. Similarly, for different functions, we have different bounding boxes. We can see here for each and every element we are having a boundary box. So this is about the original image. Now let us see the tampering image also. So these are the bounding boxes on our tampering image. The contour version of the tampering image and how it looks in terms of similarities. So here we can see that it is not much different from this one, but it has some differences in it. So we can say that the contours didn't help us in deciding whether the images are similar or not. As you can see here that there are not much differences between both the images when we are comparing with respect to the bounding boxes. Now let us visualize the difference between the images with the black, and for which we will use the image.formArray function. Let us plot this. So here you can see that it will show only the difference If there is no difference between the original image and the tampered image, we won't be seeing these black portions. These black portions only display the difference between both the images, as we have already calculated the difference, and that difference is used here in the different images, and the difference is shown in black. The black portion, as you can see here in the image, which will shows the difference in the original image and the tampered image. Similarly, we can find out the threshold with white. Let us visualize that. So here we can see that the threshold difference between the original and the tampered one is really high. And you can see that it has a much difference because a white portion has acquired most of the space in this image. So we can say that the images are not similar as they are different from each other up to a certain extent. So from both these images, the different images and the threshold image and the SSIM score, we can conclude that the image which the user has provided to us is different from the original image. That is, it is actually a tampered image. And you can see how easily we have calculated. We have calculated the SSIM index and came to the conclusion that the image provided by the user is a tampered one.